Hello guys, in today's video we'll go over chromium trioxide. Chromium trioxide is a very important inorganic compound which is used in quite a few organic reactions as well. So let's get into it. The chromium trioxide, it is it is the acidic anhydride of chromic acid. An acidic anhydride is a type of chemical compound derived by the removal of water molecules from an acid. So basically we took the chromic acid molecule, and after the removal of water molecules what we end up with is chromium trioxide. It's CrO3 chemically. Millions of kilograms are produced annually, mainly for electroplating, so you can understand how important it is for the electroplating industry. Chromium trioxide is a powerful oxidizer and a carcinogen, so it has serious health implications to humans and other life forms. Here you can see the crystals of chromium trioxide. It is dark purple solid under anhydrous conditions, so you can easily get to know that this image was taken under anhydrous conditions. It is bright orange when wet and which dissolves in water concomitant with hydrolysis. So as it dissolves in water, it hydrolyzes as well. Now let's look at the production. In the production, chromium trioxide is generated by treating sodium chromate or the corresponding sodium dichromate with sulfuric acid. So we have sulfuric acid and sodium dichromate, and we get our uh, CrO3 molecule, which is chromium trioxide. We can have a look at the reaction here as well. You can see in the first image we have a concentrated solution of potassium dichromate. Taking sodium dichromate or potassium dichromate really doesn't matter because the sodium or potassium are counter ions. The first image shows a concentrated solution of potassium dichromate in water. Now sulfuric acid is being added into the solution, and what we end up with are these beautiful crystals of chromium trioxide. This is the crystallization process. Now, the solid consists of chains of tetrahedrally coordinated chromium atoms that share vertices. So this is about how it exists in the solid state. Each chromium center therefore shares two oxygen centers with neighbors. You can see there are two oxygens being shared. Two oxygen atoms are not shared, giving an overall stoichiometry of 1:3, which is, as you can understand, the two oxygen atoms give a complete contribution while two give half contributions, so effectively we get three oxygens per chromium atom. Chromium trioxide decomposes over 197 degrees Celsius, liberating oxygen and eventually giving us Cr2O3. So you can look at the reaction here, it decomposes giving us Cr2O3. Now let's look at some importance of this reagent. It is used in organic synthesis as an oxidant, often as a solution in acetic acid or acetone. It is soluble in both of these in the case of Jones oxidation. In these oxidation, the chromium 6 converts primary alcohols to corresponding carboxylic acid and secondary alcohol to ketone. So you can see the primary alcohol has been converted to a carboxylic acid right here, while the secondary alcohol has been converted to a ketone. Now I'd like to point out that it is not always that the primary alcohol gets converted to carboxylic acid. Under some conditions, in the presence of CrO3, say with pyridine, or when Sarret oxidation occurs, I've made a video covering that as well. All we get is an aldehyde, as it is not, the process is not rigorous enough to get a carboxylic acid. So you must not just remember it as it would always convert it into the carboxylic acid. It can, or it can also convert it into the aldehyde state. Now let's look at a few applications. Chromium trioxide is mainly used in chrome plating, electroplating, which did that before. It is typically employed with additives that affect the plating process but do not react with the trioxide. Of course, if it would have reacted with the trioxide, our yield would have been very low and the process wouldn't be economical anymore. The trioxide reacts with cadmium, zinc and other metals to generate passivating chromate films that resist corrosion. So you can now understand why it is used as used in the plating industry. It is also used in the production of synthetic rubies. Chromic acid solution is also used in applying types of anodic coating to aluminum, which are primarily used in aerospace applications. A chromic acid phosphoric acid solution is also the preferred stripping agent of anodic coating of all types. So you can see it is very useful in the industry of electroplating, and it has very high application in aerospace industry as well. So it is a very important reagent, which was pretty evident by the amount which I had mentioned before. Millions of kilograms are produced annually. So now let's look at the safety issues. Chromium trioxide is highly toxic, corrosive and carcinogenic, which we did before. It is the main example of hexavalent chromium, an environmental hazard. So it is an environmental hazard. Chromium 6 compounds are generally hazardous to the environment. The related chromium 3 derivatives are not particularly dangerous. Thus, reductants are used to destroy chromium 6 samples. So due to these bad properties or harmful properties of chromium 6, when we need to destroy them, we use reductants to convert them into chromium 3 derivatives. Gain of electrons is reduction. So you can clearly see electrons are being gained, as from the +6 state it came to a +3 state. So 3 electrons are gained in this process. Chromium trioxide, being an powerful oxidizer, will ignite organic material such as alcohols on contact. Hence you can see that even in labs it can be very dangerous, and so it has been replaced by many new reagents as well.